So in this video, we're going to be looking at another workflow in LangGraph, and that is the Orchestrator-Worker workflow. So imagine that you have a PDF file. You have a PDF file, and your PDF file has multiple pages. So let's say it's a book. So you have a PDF file. Let me make this without a background. And your PDF file has multiple pages. So you have another page here and another page. You get the gist. So your PDF file has multiple pages. Now you want to summarize the entire book. So this is a book. This is an entire book. Let's call it book with numerous pages. And you want to summarize all the pages in this PDF file, this book. Now you want to delegate that to nodes that can summarize, but you're going to be giving each node different pages. This book has different pages: page 1, page 2, page 3, page 4, up to page n. And you want to give that to individual nodes. You want to break it down into pages because you want to summarize the entire book. You break the book down into pages and you want to summarize the entire book, or you want to even summarize it chapter by chapter. Summarize chapter 1, summarize chapter 2, summarize chapter 3. And you know that you have to pass this to summarization nodes. So this node gets one chapter. Let's just go by chapters now. This node gets one chapter. Another node gets another chapter. And a third node gets the third chapter. And the end node gets the end chapter. Let's make this dashed now. And yeah, gets the end chapter. So you're going to be giving each of these nodes different information. In this case, chapters. You're going to be giving them different chapters to process. And you don't know, you want this workflow to work for any type of book. And books have different number of chapters. There's no fixed amount of chapters every book in the world must have. So you have some books that have 5 chapters, some books have 10 chapters, some books have 13 chapters. So you have to be able to dynamically spin up these nodes and pass them different states, that is different information. And each node is going to summarize its chapters. And at the end of the day, you're going to gather everything. From node 1 to node n into a single document. You're going to gather everything into a single document that will then be your final summary. Let's give these different colors. Maybe it's going to like improve the visualization. Let's see. This blue. Yeah, that works. Yellow. Yeah. So at the end of the day, you pass all your chapters into nodes, into summarization nodes, and each summarization node is going to summarize each chapter. And at the end of the day, they're going to aggregate and synthesize everything into this final summary. Let's call it final summary. Good. Yeah. So this is basically how the Orchestrator-Worker workflow runs. This is how it runs. You have a complex task. You want to break it down into subtasks, and you want nodes to work on each task. And when they finish working on each task, they can bring everything together and give you the final output, the final result. More like a map reduce process, like we saw in the send lesson for performing map reduce. And we're going to be seeing send in this operation also, because send is what LangGraph basically uses to execute this workflow. But basically, this is how the Orchestrator-Worker workflow works. You use a central orchestrator to break down a complex task into smaller tasks. Then you dynamically create nodes, and to each node, you delegate a subtask. To each node, and those nodes are called workers. These nodes are called workers. And this is your orchestrator. So your orchestrator gets to break down the book into chapters, and those chapters become the subtasks. It then passes it to these worker nodes, which are the summarizers. They're the summarization nodes, and they perform their summaries on each chapter and aggregate everything into a final summary. So once the workers are done, the workflow synthesizes the workers' outputs into a final result. The orchestrator is the one that manages the overall workflow, while the workers just focus on their specific tasks. They focus on solving the pieces that have been given to them. That's basically how the orchestrator-worker workflow works. Now, let us look at the advantages of using this workflow. First, it helps you to handle dynamic complexity. Just write that down so that you see something on the screen. Yeah, so it helps to handle dynamic complexity because you can simply break down tasks to the number of subtasks. You don't need to know this number of subtasks in advance. You can simply take a complex task, break it down into subtasks, and you don't need to know the number of subtasks in advance. So you can dynamically handle complexity. Another thing is that it enables you to perform parallel processing. Parallel processing. So you're able to perform parallel processing in that you can take each subtask and operate on them independently, and all the subtasks get to run simultaneously. Each worker performs his work independently and all the workers are running simultaneously. So parallel processing, just like in our parallel workflow, but this time you are doing it dynamically, but also running operations in parallel. Also, you have coordination. Because the orchestrator node, let's write that here, coordination. The orchestrator node gets to coordinate the entire activities of the worker nodes and also collect their results and decide what to do with their results. So the orchestrator helps you to manage the breaking down of the task. There can be different criteria with which you want to break down the complex task into subtasks. So the orchestrator helps you to manage that, and it also helps you to synthesize the results. That is one of the advantage. Another thing is that you can scale dynamically. Let's have that on the board too. You can also scale dynamically. Yeah, good. No, that's why. That's better. Dynamically. Okay. So you can scale dynamically in that you can create as many workers as necessary for the task. Yeah, you dynamically spin them up. They are spun up on the fly. So you can easily scale your operation dynamically. It also provides for separation of concerns because the orchestrator manages the breaking down of tasks, manages the synthesis, while the workers just focus on handling what has been given to them. So with this workflow, you can have separation of concerns. That's also one of the advantages of using this workflow. The orchestrator is responsible for breaking down the tasks, while the workers simply focus on what they are to handle. So yeah, those are the advantages of using this type of workflow, and it also kind of informs when to use this type of workflow. But let us look at some use cases. One is code refactoring across multiple files. So here you can have your orchestrator identify which files need updates. You create a worker for each file to refactor, and then you can synthesize all the changes, ensuring that you have consistency across your code base. So code refactoring is one of the use cases. You can also use it to manage large data sets. You can use it to analyze large data sets. An orchestrator can help you split a large data set into chunks. Then you can create workers, and each worker is going to analyze each chunk. Then you can aggregate statistics and insights from all the results produced by the workers. Another use case is distributed testing. So in distributed testing, you can use your orchestrator to identify different test cases to run. Then you create workers for each test suite. And at the end of the day, you can aggregate all your test results into a final test report. So yeah, that's the orchestrator-worker workflow. We've looked at the advantages of using this workflow. We've also looked at use cases where this workflow can be applied. And now let us see how we can use it in code. So in this video, we're going to be running a demo to showcase our orchestrator-worker workflow. We're going to be creating a research report generator. This research report generator will be given a topic. Then an orchestrator node is going to take that topic and break it down into subtopics or aspects to research on. We'll then spin up workers to research on each aspect that has been given each subtopic. And then once the workers are done, the results are collated and synthesized into a full final report. So that is our demo. I'm going to be creating a new file for that, and that will be the O212. I will call this Orchestrator -worker workflow, or just orchestrator-worker.py is okay. Orchestrator-worker.py, and let us get started with our project. Now, the first thing we're going to do is to bring in our chat model. We want an LLM to power this, so we want to bring in a chat model. Let us bring in our OpenAI library. You can use any LLM you want, as long as you get the LangChain implementation right. But for this, we're going to be sticking with OpenAI. So let's import chat OpenAI. Then let us bring in our graphing tools. Here we'll get state graph, start and end. Then we're going to need send. So from langgraph dot types, we're going to need the send API. So bring in send. That's what we're going to be using to dynamically assign work to nodes. Then we're also going to bring in some classes from the typing library. That will be typedict, list, and annotated. Then we want to aggregate our results into a particular state channel. And to do that, I'm going to be bringing in the add method from operator. Then for our models, just going to bring in Pydantic. We import base model and field. We're going to be using this to define some of the structured outputs that we're going to need along the way, because the orchestrator is going to need to produce structured outputs. So this would help. Now let's begin writing our main application, starting by defining our overall state. Now we're going to be defining two types of states for this demo. We're going to be defining an overall state that will be for the entire graph. Then for each worker node, each of them would operate in a private state. Each worker node is going to operate in a private state. So we're also going to be defining a private state schema for each worker node. So let us define our overall state first. I'm going to say class overall state, pass that typedict, and the first channel we're going to create is for the topic we want to research. So research topic, and let's just set that to a string. Next is sources. I'm going to call this sources, but it's just the breakdown of the topic into different subtopics. So it's a string, and the next thing is going to be worker findings. So our worker is going to be investigating each source and research for us and return some findings. This will be annotated, be a list of dictionaries, because each worker finding is going to be sent back as a dictionary. And for the reducer, we're just going to input the add reducer. So what we're trying to say here is that we'll take this research topic. Our orchestrator is going to break it down into different research headings. We'll call them sources. Then our workers are going to research these sources, and whatever they find is going to be collated here. That's why it is a list. They're going to be returning dictionaries. That's from their research. The workers are going to be returning dictionaries. So this is going to be a list of dictionaries. And because we're going to be gathering them here, we need a state reducer that's going to help us append each worker's research finding into this worker findings channel. So that's good. And in our aggregator node, we're going to have a final report that we're going to generate that will be set to a string. Yeah. So that's good. That's for our overall state. Next, we need to define the private state that our workers are going to operate with. I'm going to call that worker state. Feel free to call it any name you want that is descriptive for the purpose in your application. But in this demo, we're just going to call it worker state. Now for here, each worker is going to be taking a source. That is one of the sources in this list. And we're going to have a worker ID just to uniquely identify our workers. That'll be an int. And going to say research topic. Let's give it a research topic, just so that he has that in context. So yeah, that's good. The next thing we need to do is create the output of the orchestrator. Now, as I mentioned earlier, the orchestrator needs to provide or produce a structured output, because that's how we can then pass information to our worker nodes. We can't pass information to our worker nodes from raw LLM text. We have to get a defined data structure that we can then distribute to our worker nodes. And like I said, what our orchestrator is going to be doing is taking this research topic and breaking it down into sources. So that means we want to get some sources back. So I'll just create a new class and say research plan, a base model. And here the first thing we're going to define is our sources. This is going to be a list of strings. And we're going to define it as a field, as a pedantic field. For the description, we'll say list of specific research sources or aspects to investigate. And we want to restrict how many of that the LLM suggests. So we'll give it a max length of 5. So don't suggest more than 5 sources. We don't want to just keep going on and on and on and on. Then the next thing we will define is a helpful class property called reasoning. And what reasoning would do is just to make the LLM give us the thinking behind choosing the sources it has decided to choose. So we'll say brief explanation of why these sources were chosen. Yeah, so we don't just want it to just return sources without context. So we want it to tell us why these sources were chosen. So that's good. We have our state schemas defined, and we also have our structured output schema defined. The next thing we're going to do is set up our LLM. So let us instantiate that. Say LLM equals chat OpenAI. I want to use the GPT-4o model. So good, we have our LLM defined. Now we need to create our nodes. And we're going to need 3 nodes. The first node is going to be the orchestrator node, which is going to take our topic and slice and dice it into different sources or different talking points. Then we're going to create an instance of our worker node. That's the worker node that is going to be duplicated, but given different parts of the breakdown that the orchestrator has done so that it can work on them. Each worker node that spins up can work on each part or each source that the orchestrator node returns. And then we have our synthesizer node. This is the one that will collect all the findings from our worker nodes and prepare a final report from that. So let us start with our orchestrator node. So we'll say orchestrator, and I'm going to call that function plan research. Plan research is going to take in a state of the type overall state, and it's going to return overall state. Now you know I like print statements, so we're going to print something here. I'm just going to print, let's put a new line here first and add that to 70 dashes. Good. And under that, I'm also going to print 70 dashes. just as the divider for the title I want to put here. And in between that, I'm going to say print, and here we'll say orchestrator. Let me see if I can put a robot emoji there. Yeah, I'm the emoji guy. So this is the orchestrator, and here we're going to label this as orchestrator and say planning research strategy. Planning research strategy. So that's good. Let's print our topic. Here we'll say topic is, and we can get that from the state. Our topic is research topic. And let's just stick a new line character there. So yeah, here we'll be able to know that our orchestrator is running. It's always good to add all these labels, especially when we're running examples, so that we can see where a particular action is taking place. So let us get to planning. First, we need to augment our LLM. So I'm going to say planner LLM equals LLM dot with structured output. Then we can pass in our research plan schema. Give it to this. Good. And then we can then write our prompt. So we need to produce a structured output, like I said, from our orchestrator so that we can get a data structure that allows us to distribute to worker nodes. That's why we're creating our planner LLM, which we have augmented with our research plan schema. So now let us get our prompt. The prompt is a bit lengthy, so I'm going to bring it in and explain. But you can find it in the project files, in the GitHub repo for this course. You can find it there and you can play around with it. So I'll just paste the prompt here. It's good. Now this prompt says you are a research strategist planning a comprehensive investigation. The research topic is this, which we are getting from state. Critical instruction: generate between 3 to 5 specific research sources or aspects to investigate. Do not generate more than 5 sources. Each source should be specific and focused on a distinct aspect, relevant to the overall topic, complementary to other sources, minimal overlap. We don't want duplicating sections or being repetitive. Then concrete enough to guide targeted research. Examples of good sources. It's always good to do this with your prompts. Short them with some examples. So clinical trial results and efficacy data, economic impact, and blah, blah, blah. Just give it a bunch of topics so that it knows how to craft its top talking points. It knows how to craft them the way you would like. Then generate sources that will provide comprehensive coverage of the topic. This is also a very, very important instruction to give to the model so that it doesn't just generate things that are not coherent or doesn't have the proper cadence. And also you want it to generate them in such a way that it covers the topic from a starting point to a sufficient ending point. So yeah, that is our prompt. Now let us generate our research plan. And here we're going to take our planner LLM and invoke it with our prompt. That's good. Now to observe the output, let us see what it is able to give us. I'm going to say print, use f string there, and say orchestrator generated. Then let's get the length of what we got back from our orchestrator. That will be research plan dot sources. Research plan dot sources, because that's where we told it to keep our sources. Research plan dot sources. So we get that. And let me just complete this by saying research sources. So it will say orchestrator generated so number of research sources, which is good. Next, let us take a look at them. For I source in, let's enumerate that so that we can get our I. Enumerate. And I'm just going to copy this, which research plan sources. want to start at 1. And here we can simply say print the number and the source, the position and the source. So this is good. We're printing out our sources so that we can see it when it is generated. We know that we're generating some sources there. And then we can also print the reasoning behind this. And I'm just going to go emoji again and say I want a light bulb here. Do I have a light? Okay. Light bulb. So we say our reasoning. And we'll just say research plan dot reasoning. Research plan dot reasoning. And here I'm just going to add an action point that says preparing to dispatch to nodes. Yeah, preparing to dispatch to nodes. So yeah, we're done with all the printing out, just to make sure that we're getting stuff back from our orchestrator node. But the very important thing, the most important thing, is to make sure that we return our sources back into state. The sources that have been generated from this orchestrator node, let us pass it to state. So that will be research plan dot sources. Good. So that's our first node, our orchestrator node called plan research. It is going to break down our topic into different sources, and we can then start researching those sources. So let me jump out of this function. Then we can collapse it. And the next node we're going to be creating is our worker node. We're going to be creating our worker node next. Now, this worker node is going to take in a private state, but return back to the overall state. It's going to return its results back into the overall state. It will receive data in its private state, and it will return the result into the main state so that the reducer can add it to the aggregated results, and the orchestrator can decide what to do next with it, or the synthesizer node can then grab that final list of outputs and prepare a final report. So let us create our worker node. Say worker node, and I'm going to call that research worker. Research worker is going to take in the worker state, but it returns back into the overall state. That's good. First, let's get a worker ID. Worker ID from state. We're going to be passing in a worker ID. We're going to be generating worker IDs and passing it into this private state when we are spinning them up. So say worker ID, then source. The source will be what has been passed to it as the piece of the generated sources that it is to work on. So get those two. Let's add the print statement here. A worker node that is researching. That would be like let's do magnifying glass. Yeah. So say worker and specify its worker ID. Then we'll say researching and call the source. So as we're researching this source, let's put some quotes around here and say dot dot dot. Okay. So we get our worker node or our worker ID, we get our source. You will still see how we'll pass these two in when we're doing when we're adding the edge, the conditional edge. Then we just say the phrase. Then we just add a print statement that shows that these are our worker of this worker ID, and it is currently researching this particular source. Now let us bring the prompt that is going to instruct this worker node on what to do. There's also an elaborate prompt, so I'm just going to bring it in and we'll go through it. So here we paste in our prompt. Now let's read through. It says you are a specialized researcher investigating the research topic, the entire research topic. Your specific focus area is this source. Conduct thorough research on this aspect and provide 1. Key findings, 3 to 5 specific points. That's the most important discoveries or facts under this talking point. Data and statistics, relevant numbers, percentages, or quantitative information to back up the claims. Insights and analysis, sources and credibility, and implications. Why does this matter for understanding the overall topic? And you also see why it was important that we pass in the overall topic to this private state. It gives it more context on what the piece of that topic it is to research on. So it gives it context about the overall topic so that it knows how that subtopic fits into the big picture. So provide specific, or rather be specific, factual, and provide depth on this particular aspect. So that's good. It knows what to do. Let us fire this prompt into our LLM. Here we don't need to use the augmented LLM. The normal LLM is fine because we want to generate text for that section and not a structured output. So we'll say invoke prompt dot content. On the content, then we're going to create a findings dictionary because we want to return a dictionary as is defined in our state. Each worker returns a dictionary, and inside that dictionary we're going to have the worker's ID, set to worker ID, the source that was researched, and what we got back from our research. Good. Then we can just add a nice print statement here that shows that we're done. Like putting a check mark to that so that we know what it does. Yeah. So, by the way, feel free to ignore my emojis if you are not a fan. So, worker with this worker ID, I think I just copied that from here. Say worker with this worker ID is done. Say research complete. Research complete. That's put a new line there so that it doesn't affect any thing that comes after it. Now the most important thing we need to do from this worker node is that we need to return our worker findings back into state. We need to return it back into state. Now we got one finding. Let's say findings. We got one finding from this worker, and like I said, let's just go back up here. These worker findings from the overall state is where we want to aggregate all our findings from each worker. So they need to return back to that state. And like you can see, we made it a list of dictionaries and we gave it the add operator function as its reducer. So whenever we pass a new finding into this list, it will be appended to the list. So we scroll down and we say worker findings. We can simply pass in our findings into a list. So it just add that. It just add that to what's already there, based on the sequence with which each node finishes its operation. So yeah, we have our findings being sent back into state, and we're done with our worker node. Now to create our final node, which is the node that is going to gather everything together. That's all the research done by each node and put it together into a final report. So here we say synthesizer. I'll call it, def synthesize report. Give it state, overall state, and it will also return overall state. So First, I'm just going to quickly add some print statements here to show that we are now in our synthesizer node. So print synthesizer. Let's take some notes. Yeah, this guy. So this will be the synthesizer. And to say combining insights from all workers. Combining insights from all workers. Then I'm just going to repeat this under. Don't worry, all this is going to be useful when we are visualizing. You don't want to be running things in the console and you don't know what exactly is happening when. So yeah, say print processing findings. Processing. Processing findings from all the worker findings. So it will be states, worker findings. I'm just going to say research findings. Oh no, research sources. Yeah. So the findings are from the sources. So yeah. Now let us get all the findings all together. I'm going to say all findings. All findings equal. First, let's get double new line here. Let's put a delimiter, make it 70, and also add it to another double new line. Then we can say all findings plus equal a double new line once again, and we want to call the join function, pass it a list, and for each of the finding we want to say research area, search area. Now I'm going to have a loop, but let's put a loop down here. Let's put a loop down here so that it doesn't look like something just appeared from nowhere. So for f in state worker findings, yeah, good. So then we can say f worker ID, f worker ID, and f source. Put a new line after this, add some dashes, and then put the content on a new line. Okay, so yeah, we're going to loop over our worker findings. Then for each worker ID, we're searching the source. We create a new line, add some dashes, and we'll put the content for the findings. That's the content that we're returning here. We scroll down, you'll see it here, content. So for each of the findings, we want to just display what we found. So let us have that there on display. So that will just display what we got from each finding. But then let us instruct what the synthesizer is actually going to do. So I'm going to grab the prompt for that and get back. Let's paste that here. And now let's go through this prompt. It says you're synthesizing a comprehensive research report on this research topic. You have received detailed findings from the worker findings. Specialized researchers, each investigating a different aspect of this topic. So we give it all the findings, all the research findings that we built up here. All the research findings we built up here, we give it to it. So it then says create a cohesive, well-structured research report, 500 to 700 words, with each of the following sections. Executive summary, that's provide a high level overview of each takeaways. Then introduction, the context and importance of this topic, the scope of this research. Then the key findings. So you take all the findings and you integrate insights from all of the research areas, organize them thematically rather than by source. So let them flow in the right order. Then use specific data and examples, which you can also get from the information that they returned. Then analysis and synthesis, identify patterns across each research areas, highlight connections and relationships, and note any contradictions or tensions. Then talk about the implications and finalize with some main takeaways and areas for further research. Then some important instructions to wrap up. Write these as a unified flowing report, not as separate sections from each researcher. So don't just do what some people call cut and join. Make it flow. You are not to use the content as is. Actually, just feed from the content and use it to build a proper article from top to bottom. Then integrate findings naturally across teams. Use specific examples and data from the research and make it professional and authoritative. So, good. Very well detailed prompt. Now let us process our prompt. This is going to be our final report. Say final report equals llm.invoke our prompt, and we can get our content from that. That's good. Let's also indicate that our synthesizer is done. Come here. It's turned out to be a very long example, but like I said, real world examples, that's what we want to see here. Makes it more fun and make you understand where these strategies are actually needed. So synthesizer, say final report complete. And we can simply return that final report back into state. So final report. Awesome. Now we're finally done with our nodes and we're at line 188. So yeah, we have our orchestrator, our worker node, and our synthesizer. Now we need to take what we get from our orchestrator node and dynamically spin up worker nodes. We need to do that, and that will be done using a conditional edge. We're going to use a conditional edge that will spin up a bunch of send commands, and each send command is going to take a piece of the data, that's a source, worker ID, and the research topic itself, and pass it to a worker node. It's going to pass each of them to a worker node. So let us build that up. Let's write the function that is going to perform the conditional edge. So I'm just going to say conditional edge function, and that will be create research workers. Create research workers is going to take in the overall state, and here let us know that this is where we are. I'm going to put this road sign emoji, and I'm going to say dispatcher, say creating research workers dynamically. Good. And we're going to then spin them up. So to spin them up, we're going to be returning a series of send commands. That's how you spin them up dynamically. Like I said, if you still don't know how send works, do well to check the send lesson in the LangGraph fundamentals. So we need to return a list of send commands, and we'll say for I source in rate, and here we get our sources. So from our sources, not courses, from our sources, we look through over our sources here, and for each of the source, we want it to send. We want it to send to a research worker node, want to send to a research worker node. And what do we want to send? We want to send this piece of data. I want to send this piece of data. First is the source itself. So send the sources to research. We also want a worker ID, which you can generate with any strategy you want, but for now I'm just going to be using the iterator count. And also we want to send the research topic for context. So it's a research topic. And we want to send research topic, which we'll get from the state. So research topic. So loop through our sources, and for each of them, use this send command to spin up a new research worker node and give it this piece of data that goes into its private state. Yeah, so that's everything. That's everything for our conditional edge. And now we can build our flow. We can build our flow and our entire graph. So let's start that. Let me say build graph. So first, I'm going to say builder equals state graph. And here we'll pass overall states. Our state schema. Next, let us add our nodes. So I'm just going to say builder.add node. And the first node we're going to add is our orchestrator. We're going to name it orchestrator. And this is going to be set to our plan research function. Then we add our next node, which is the research worker. And we'll set that to our research worker function. Then we add another node. That will be for our synthesizer. We'll call it synthesizer. And that will be our synthesize report function. So we've added our 3 nodes. Now let us build the flow. Let's build the flow. So for our edges, we say builder.add edge. And we want to go from the start node to the orchestrator. Start node to the orchestrator. Then from the orchestrator, we then go to all our worker nodes. So we need to add a conditional edge. Say .add conditional edges. And for that, we want to go from orchestrator. And then we pass it this function. Pass this function that is going to go to worker nodes. And for each of them, just go to research worker. Even though send is going to do that, but let's just have it here. So this is good. Then finally, let us go from all the research workers. Go from all the research workers. I'm just copying that from here. Go from all the research workers to the synthesizer. And once we are done synthesizing and building our final report, we can terminate the graph. That's awesome. That's awesome. Now let us compile this graph and use it. Let's compile the graph and use it. So I'm going to say builder, or graph rather. Graph equals builder.compile. Which is good. Now to test our graph, I'm going to be bringing 2 topics. I'm going to be bringing 2 topics, and you can play around with each topic. I'm going to be running one of them, or I might just run 2 of them, but I'm going to bring in 2 topics that we're going to use to test out this. So let me just grab that. So I'll paste those in. And here we have a healthcare topic that says the impact of artificial intelligence on healthcare delivery and patient outcomes. And we have an environmental topic that says renewable energy adoption barriers in developing countries. So you can use any of these topics to play around, and you can also create your own topics. So yeah, I'm going to take a topic variable which we're going to be alternating for any of our topics. So I'll start with the healthcare topic, and here can run our graph. Let me start with my borders again. Middle here we can print our topic, and say topic. Okay, so then we can run our graph. So result equals graph dot invoke, and we can pass it our initial state. For our research topic, we just say topic. Our sources, we'll start with none. We're starting with 0 sources, so there's no initial sources we're passing. Everything comes from the orchestrator. Then our worker findings will also be set to an empty list. It's good. Now we can come down here and print our result. I'm going to copy this because I'm doing something similar down here. Now here we'll say final synthesized result. And then print our output. That'll be result, final result, or final report. I think it was final report. Final report. So we get our final report from our state. That's here. Final report from our state, and print it out. So yeah, that was a lot, but it's all to clearly show how this workflow is implemented. And now we can run it. Now make sure that you have your API key in place. So ensure that you have your API key in place. Also make sure that you're in your virtual environment. Sometimes you can make that mistake and just want to run your code without activating your virtual environment. And now we can say Python O2 workflows O2 12 Orchestrator-Worker.py. Now we typed a lot of stuff and there might be some errors, but let's just hope we don't have any errors. If there's any error, we'll fix it anyway, but let us just run the code and see what we get. So yeah, our topic, the orchestrator is planning the research strategy, so it's generating its sources. So get an error here, says worker ID. It can't find worker ID here in state. That should be inside our research worker node, so it can't find the worker ID. Let's go up, see if there are any errors too. So it was already dispatching here, so yeah. So let us test that because it's already giving us some results here. Let's close this. Let's see what we got wrong. So research worker, state worker ID, the source. Let's go down to where we are dispatching to see whether we gave it the right worker ID. Oh yeah, that's where the error came from. So we go to worker here instead of worker ID. Sorry about that. That's my mistake. So worker ID. Let's close this. Pull up the command line and let us run once again. Like I said, we did type a lot of stuff, so yeah, there might be a couple of errors. So planning again, generating sources, and now we can see the workers. We can see the output of each workers: worker 1, worker 2, worker 3, worker 4, worker 5, because we're actually spinning up 5 of them because we told our LLM to give us 5 sources. So now it should be going to the synthesizer node so that it generates our final topic. Oh, the workers are actually just completing, so, and they're completing out of order, as you can see. Race conditions. Completing out of order. Number 1 finished first, number 2 second, then 4, then 3, then 5. Then synthesizer is combining insights from all the workers, processing the findings from all the research sources, And in no time, we should be getting our final report. And yeah, we get our final report in Markdown. The final report, when we scroll up, we have our executive summary. Artificial intelligence is becoming a transformative force in healthcare delivery and patient outcomes, blah, 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 blah. Our introduction, the key findings, where it actually makes use of what we got. Did analysis and synthesis, implications, and then conclusions. Very specific on how many words that we want, whether we wanted it to be a 1,000-word article or a 5,000-word article or a 5,000-word report or everything. But those are things you can also specify so that you can know how elaborate it should be. But this is quite compact and it follows exactly what we want it to do. We see our let's scroll up a little bit from the very beginning. So we can see our topic. The orchestrator started planning. It then generated 5 talking points. And it gave us the reasoning behind it. These sources were chosen to provide a holistic view of AI's impact on healthcare, and it gave more details why each of them was chosen. Then our dispatcher dispatched to the nodes dynamically. Then worker 1, worker 3, worker 2. You can see it's even out of order because it's not doing it sequentially, it's doing it at the same time, simultaneously. Then it also started completing its research. 1, 2, 4, 3, 5. Then the synthesizer took everything from all the workers, synthesized it into a final report, and now we get our final synthesized result. How awesome is that? That is how you use the Orchestrator-Worker workflow.